Hello students, today in class 12th I will tell you about the magnetic field lines or magnetic lines of force. These are similar to that of electric field lines that I have told you in the chapter of electrostatics. Just like the electric field lines, we are having the magnetic field lines. The imaginary smooth ends continuous curves which are the path of freely moving unit north pole in magnetic field are called magnetic field lines. The imaginary smooth and continuous curves which are the path of freely moving unit north pole in magnetic field are called the magnetic field lines. So these curves are not visible to us. We see that there are the fields like the electric field, magnetic field, gravitational field. These fields are not visible to us. We can experience them. We can have so many phenomena related with them, but these fields are not visible. So just to make the visible to these fields, we have the idea of these magnetic field lines. As you see that I have written in the definition that these lines are imaginary, smooth and continuous. So there is the curves which are made by this freely moving unit positive charge, they are called the magnetic field lines. Properties. Number one, the magnetic field lines represent the magnetic field in space. Number two, these lines originates from North Pole and moves towards South Pole. Outside the magnet. But they move from South Pole to North Pole. Inside the magnet. So, magnetic field lines are closed loops. Just like the electric field line originates from the positive charge and terminates at the negative charge. But here the magnetic field line originates from the North Pole and goes towards the South Pole outside the magnet. But inside the magnet they move from South Pole to North Pole. So they make the closed loop. So this is very unlike to that of the electric field line. The electric field line is the open loop, but this is the closed loop. Suppose we are having this is North Pole, this is North, and this we suppose have the South Pole. Then here the field lines will be like this one. And here the field lines will be like this. Like this. So this is when we have taken the only the North Pole and only the South Pole. But if suppose that these are not the only North and South Pole, we are having the magnet. This is the magnet, this is the North Pole, and this is the South Pole. Then what will happen that they move outside the magnet from North to South, but inside they will move in this way from South to North. Similarly here, outside to this one, but inside now they are moving in this way. Now here from North to South, but inside the South to North. In this way, and inside to it, this will be in this way. So what we have? And in this way, and here we will have this tubing in this way. So this is the magnet. Then this is North Pole and South Pole, and this is Now suppose I take it here and this I take here, this is now south. Then the field lines will be going in this way. Here the field lines will be coming in this way. In this way. So these are the magnetic field lines of a magnet. But when we take the independent north pole and the south pole, then this is to be the like this one that we are having. So this is how to draw the magnetic field line. And now number 3. The tangent drawn at any point of field line so the direction of magnetic field. अब इसके किसी भी एट एनी पॉइंट, किसी भी पॉइंट पर अगर हम एक टेंजेंट ड्रॉ कर दें तो वो इसके मैग्नेटिक फील्ड की डायरेक्शन को शो करती है. So now suppose we are having, this is suppose a magnetic field line and here we draw the tangent, this tangent, this will show the magnetic field B. Similarly if we draw here, then this will be the magnetic field B. So tangent drawn at any point shows the direction of the magnetic field. Number 4. The magnetic field lines never intersect each other because at the point of intersection there will be two directions of magnetic field which is not possible. Magnetic field lines never intersect each other because at the point of intersection there will be two directions of the magnetic field which is not possible. So what we have, suppose like we are having this is now a field line and this is another field line like this. This is the point of intersection. So at this point of intersection this will be the magnetic field B and this will be the magnetic field B. Since there is the single magnetic field, the single magnetic field cannot have two directions. It will have only one direction. This is why that the magnetic field lines never intersect each other. Number 5. The density of field lines in a space shows the strength of magnetic field. तो क्या मैग्नेटिक फील्ड है जितनी डेंस होती हैं मैग्नेटिक फील्ड उतना ही स्ट्रांग होता है, और जितनी डेंसिटी इसकी कम होती है उतना ही मैग्नेटिक फील्ड कम होता है वो. सो दिस विल शो लाइक दिस वन. Suppose this we have the lines of force like this. This shows you the strong and uniform magnetic field. Strong and uniform magnetic field. If we are having the lines like this one, in this way, suppose this line is like this, then if the line is in this way, then this shows the weak and non-uniform magnetic field. Weak and non-uniform magnetic field. Magnetic field. This is showing you because the field lines are not at equal distance from each other. It means that the field is non-uniform. Moreover, the lines are away from each other, they are apart from each other, so they are not equally spaced. So this is the non-uniform and the weak magnetic field. If we are having the lines like this, or like this, if these are the lines, then this shows the variable magnetic field. Variable magnetic field. So just by these lines we can represent the uniform, non-uniform, weak and strong magnetic fields. The magnetic field is said to be strong when the lines are very close to each other and equally spaced, and when the lines are apart from each other but not equally spaced, then this is the non-uniform and the weak magnetic field. When these lines are in the form of a curve, then they represent the variable magnetic field. The number of magnetic field lines passing through unit area is called magnetic flux. Magnetic flux. That I will tell you later on, because this magnetic flux is a very important physical quantity, which is just like the electric flux. So these are the properties of magnetic lines of force. So you sometimes these lines are always originate perpendicular to the north pole and terminate at the south pole, which is in the perpendicular position. So now we are having one more characteristic of this one. The magnetic field lines emit perpendicular to north pole and terminate perpendicular to south pole. तो ऐसा नहीं है कैसे भी ये उससे एमिट हो जाए, कैसे भी टर्मिनेट हो जाए, ऐसा नहीं होता है। ये जैसे ये नॉर्थ पोल है तो यहाँ से परपेंडिकुलर ऐसे निकलेंगे, फिर उसके बाद फिर ये टर्न ऐसे होती हैं और यहाँ पर आएंगे तो इसके परपेंडिकुलर ही इस पर ये इंसिडेंट होंगे इस पर। तो magnetic field lines emit perpendicular to north pole and terminate perpendicular to south pole. So these are the some properties of the magnetic field lines. So thank you very much.